Welcome to this session on CCNA tutorial, Network Fundamentals. This video is aligned with Cisco's official CCNA 200-301 exam blueprint and is designed to guide you step-by-step towards certification success. In this lesson, we cover Section 1.8, Configure and Verify IPv6 Addressing and Prefix. We'll go through how to configure and verify IPv6 addressing and prefixes. You'll learn how IPv6 addresses are structured, how prefixes and interface IDs work, and the main ways to assign IPv6 addresses in a network. IPv4 has served the internet for decades, but its 4.3 billion addresses just aren't enough anymore. IPv6 fixes that, with 128-bit addresses, giving us an almost unlimited number of unique IP addresses. It also improves performance, with faster packet handling, built-in IPsec security, automatic address configuration, and more efficient routing. Most networks today use a dual-stack model, running IPv4 and IPv6 side by side during the transition period. An IPv6 address is 128 bits long, written in 8 groups of 4 hexadecimal digits separated by colons. Each group, or hextet, equals 16 bits. IPv6 is case-insensitive, supports zero compression, and is designed for efficient, hierarchical routing. Each interface can have multiple addresses, for example, link local, global, or unique local. To read or calculate IPv6 values, remember that every hex digit equals 4 bits. For instance, the hex value A converts to binary as 1010 and F as 4 ones. 9ACF is one 16-bit hextet, and when you stack 8 of them together, you get the full 128-bit IPv6 address. IPv6 addresses can be long, but you can make them shorter. First, drop any leading zeros inside each group. Second, replace one block of consecutive zero groups with a double colon. You can only use the double colon once, otherwise, the address becomes ambiguous. This keeps IPv6 addresses readable without changing their meaning. Here's an example. Step 1. Remove the leading zeros. Step 2. Replace a sequence of consecutive zeros with a double colon. That gives you 2000 :10010, or 2000 :10, but not 2000 :110, because 2 double colons would make it invalid. To expand an address that uses a double colon, count how many hextets are written and subtract from 8. The missing number equals how many zero groups the double colon represents. For example, in 2001, DB8:1, 3 hextets are shown, so double colon replaces 5 groups of zeros. IPv6 uses prefix links instead of subnet masks. The prefix defines how many bits belong to the network part. Common examples: /48 for enterprises, /56 for small sites, and /64 for LAN subnets. The network prefix identifies which subnet an address belongs to, just like the network portion in IPv4. It's usually assigned by an ISP or an administrator and is used by routers for forwarding and route summarization. The interface ID is the host portion of an IPv6 address. It's usually 64 bits long and must be unique within the subnet. It can be created automatically with EUI64, generated randomly for privacy, or configured manually. Neighbor Discovery uses it to communicate locally between devices. Here's how IPv6 splits an address into the network portion and the interface ID. The prefix length, like /64, tells us how many bits belong to the network. Each hextet equals 16 bits, so 64 divided by 16 gives 4 hextets for the network. In our example, the first 4 hextets, 2001 DB8ACAD1, are the network prefix, and the last 4, :1, form the interface ID. When expanded, the 64 bits for the network and 64 bits for the interface ID, that's the standard IPv6 structure used in almost every LAN subnet. Subnetting in IPv6 is simple. Just increase the prefix length. Each extra bit doubles the number of subnets and halves the number of hosts per subnet. For example, subnetting /48 into /64 gives 65,536 subnets, each with 2 to the 64th power possible hosts. That's about 18 quintillion addresses per subnet. IPv6 addresses can be assigned in three main ways: manually, using DHCPv6, or using Slack. Let's go through each one. In manual configuration, both the prefix and interface ID are set by the admin, just like static IPv4 addressing. It's common for routers and servers where the IP shouldn't change. Always include a prefix, like /64, at the end of the address. Don't worry about the commands yet. This video focuses on the theory part of the exam. For now, just remember the key terms. We'll go through the commands and hands-on labs in a separate session. EUI64 automatically generates the host portion from the device's MAC address. The key command is simply adding a prefix and the keyword EUI-64. This gives a consistent, semi-automatic address based on the interface hardware. Some operating systems instead use random interface IDs for privacy. Slack lets devices configure themselves automatically. They listen for router advertisements, learn the network prefix, and create their own interface ID, usually using EUI-64 or a random value. They then run duplicate address detection to make sure no one else is using that address. The command is IPv6 address autoconfig. With stateful DHCPv6, the server assigns both the IPv6 address and extra details like DNS and domain information, keeping a record of the clients. The command for stateful DHCP is IPv6 address DHCP. In stateless mode, the device builds its address using Slack and only asks DHCP for extra info. To check IPv6 configuration, use ping to test reachability, traceroute to trace the path, or telnet to test a specific TCP port over IPv6. Make sure each interface has a link local address, that global prefixes are correct, and that neighbor discovery works properly. If communication fails, double-check the prefix, link local address generation, and NDP operation. Again, don't worry about the commands yet. For now, just remember the terms. We'll go through the commands and hands-on labs in a separate session. Let's recap. IPv6 addresses are 128 bits long, written in hexadecimal, and divided into a prefix and interface ID. You can shorten them by dropping leading zeros or using a double colon once per address. Every interface always has a link local address, and most also have a global one. IPv6 uses prefix lengths instead of subnet masks. /64 is the standard. Addresses can be assigned manually, automatically with Slack, or through DHCPv6. When verifying, focus on prefix accuracy, scope, and connectivity. Before moving on, take a quiz to test your understanding. Quizzes, summaries, and slides are available on ccna.academy. If you have any questions, leave a comment below and I'll be happy to help. Up next, Section 1.9. We'll explore IPv6 address types, including unicast, anycast, multicast, and how modified EUI-64 works in practice.